Hello. For this project, we decide to make a framework that allows you to train in an easy and fast way face recognition algorithms. To do so, we use a Flask app that is running in a Google Cloud Run container as the front end, and for the back end, we use Amazon Sagemaker, where we deploy the model and we interact with this deploy model also via this Flask app. So let me show you a little bit how this works. So the main idea is to train a neural network, you need a lot of images, of faces, and sometimes this could be very annoying. So we thought that the best idea will be use videos. So for example, here we can see a video where I'm doing weird faces. And we're going to choose this video, we're going to upload it, we're going to say who is in this video, in this case it's me. And after we upload the video, we're going to be able to preprocess the data in order to train our model. This is going to have two steps. The first step is going to be to cut the video on different frames, and then applying OpenCV, we are going to detect the face on those frames and we're going to crop it. You have the option, if you want, to download the faces, and you can see how the model only selects my faces.
Okay, so now that the model is trained, we are ready for some action. And here I'm just uploading a photo of myself. The model has already been trained with photos of me. We just need to upload a photo and we're gonna test this photo. And as you can see, we have here the name of the person, the probability that it was given by the model, and also the role that was assigned by the user. So this was Authenticator, and this is our amazing data science team. Joaquin Menendez, Julia Oblazova, and Azucena Morales. If you want to know more about us, please check our LinkedIn and GitHub accounts. Thank you so much for checking in. I hope you like it. We are part of Duke Meets. Thank you. For the embeddings, we use the Flask Field Connected layer from a pre-trained PDG 16-net model, which is a type of convolutional neural network architecture that is commonly used for image classification and detection. This model maps cropped images like this one, which are matrices of dimensions 160 by 160, to vectors of dimension 512. Also known as embeddings. The app lets you download the embeddings in case you want to train your own model, but we can just train the model here. The embeddings and their corresponding labels, which is the name of the person, are used to train an SVM model. We use Sagemaker to train and deploy the model. Sagemaker has a framework for scikit-learn, so it was enough to have a model script like this one. Pretty simple, huh? The way we connect with Sagemaker is through Python library Photo3. So once the model is trained and deployed, we are ready to make predictions calling the endpoint that was created. That's it.
Now we are going to perform a load test in order to emulate up to 1,000 clients in our app. Remember that we're using the Google container in our Cloud Run project. And in order to evaluate that, we're going to use Loader.io. To authorize Loader.io to perform this load test in our app, we need to add one element inside our app, in this case, this HTML tag. So now we're going to perform the test up to 1000 clients. So let's see what happened. As we may see, our app was able to hold 1000 clients during 1 minute, having peaks of 24 clients per second, with an average time of 59 milliseconds to answer.